In this video, we introduce another way of describing probability. In fact, you probably heard of it before, the odds in favor or against something. Let's get started. So to begin, we have a formal definition of odds in favor and odds against. Formally, we say that to find the odds in favor of an event, we would take the probability, remember capital P means probability, of success divided by the probability of failure. So if you know, for example, that you have a likelihood of 1 out of 6, for example, of rolling your die and getting a 2, you would say 1 out of 6 is the probability of success. And for failure, there are 5 of them which are not 2s, right, on that die. So 5 out of 6. Now when you divide 1 out of 6 by 5 out of 6, reminding you of your old math, you actually take 1 over 6 times 6 over 5. It's called multiplying by the reciprocal or keep, change, flip, depending on where you were raised. The 6's will cancel because the numerator and denominator are the same, and you'll just have 1 out of 5. So a little clue was it's just the numerators on top of each other if the denominators of a complex fraction are the same. So 1 out of 5. In other words, we would say that the odds in favor when you roll a die and getting a 2 would be 1 to 5. On the other hand, the odds against getting that 2 would actually be 5 to 1. So how would I have done that? I would have just flipped the definition here. Instead of probability of success in the numerator, I would put the probability of failure in the numerator, right? And success in the denominator. So we'd have 5 over 6 divided by 1 over 6, which reduces just to 5 over 1, or 5 to 1. So notice here that this colon is read with the word 2, okay? Also notice that when you read odds, like odds in favor being 1 to 5, odds against being 5 to 1, notice that if you add up those numbers before you reduce, here we didn't have any reduction to do, but before you reduce, if you add those numbers, they will add up to the total number of possible outcomes. 1 plus 5 is 6, and for a die that's a fair 6-sided die, there should be 6 possibilities, so that should make sense. Okay. All right, so for example here, we just mentioned the probability of rolling a 2 on a fair-sided die was 1 out of 6. We said the odds in favor of getting that 2 was 1 to 5, and that the odds against getting that 2 was 5 to 1. Okay, so that's kind of what we talked about above. All right, once you have that basic definition in mind, let me show you a little secret, okay? A little secret so that you don't have to do this division every time, right? Instead, what you could have done as soon as you said odds in favor is you could have said, I know that the answer is something to something, right? So what goes first? If it's in favor, you want to think how many ways could I succeed in rolling a 2 on this die? Well, just one way. So this is your number of success, if you will, to the number of failing options. How many failing options are there? 5, because there are 5 options where I do not get a 2. And that's a lot shorter than writing one fraction on top of another, isn't it? Yeah. Similarly, if I asked you for the odds against rolling that 2, I would start with how many possibilities are there for failing, right? Well, there are 5 ways in which I could fail, right? I could get a 1, I could get a 3, a 4, a 5, or a 6, right? And how many ways are there for succeeding? There's just the one way to get a 2 when I roll one fair 6-sided die. All right, so that's a quick little shortcut for you to get the odds in favor or odds against. And again, if these numbers, instead of 1 to 5, if they had been like 2 to 6, then I would talk about reducing. And we might see that in some of our examples coming up. All right, speaking of examples, let's try this one. Feel free to pause the video and do it on your own. It says a bag contains 3 red, 2, I said that backwards? No, I didn't say it right, I'm sorry. 3 red, 2 blue, 1 yellow, and 4 green marbles. Okay, so again, 3 red, 2 blue, 1 yellow, 4 green. Imagine now that you're going to choose 1 marble. Okay, so that is very important. Right now we're only choosing 1 item. If you choose the 1 item, what are the odds in favor of choosing a red marble? In favor of choosing a red. So feel free to try it on your own and pause the video. So if you use the shortcut here, what did we say we had to do? How many ways are favorable? Sorry, I said F for failure. Favorable, I meant for failure. How many ways is it possible to be successful is what I wanted to say here. So that would be how many ways can I succeed to how many ways can I fail. So since we want in favor, we think of success first, okay? So how many ways can I successfully get a red marble? Well, it looks like there's only 3 red marbles in the bag, so that would be 3. And how many ways can I fail in getting a red marble? Well, that would be all the other ones, the 2 blue ones, the 1 yellow one, and the 4 green ones. If you add those together, you get 7. So the odds in my favor of getting a red marble would be 3 to 7. And if I had asked you for the odds against getting a red marble, you would say 7 to 3. Good job. Notice here there's no reducing that is necessary since 3 and 7 do not have any shared factors. Also notice that because we have not reduced, if we add 3 plus 7, we get 10, which is the total number of possible outcomes. Good job. Next up, we're told to find the odds in favor of choosing green. In favor of choosing green. So again, in favor, we're going to talk about how many ways can I succeed to how many ways can I fail. Our little shortcut method, right? Feel free to use the formula as well, probability of success over probability of failure, if you don't like the shortcut. So how many ways can I successfully pick a green marble from this bag of 10? 4 ways, that's right. And how many ways can I fail to pick a green marble? Well, you can add up the others, 3 reds, 2 blues, 1 yellow. That's a total of 6, or 4 to 6. Now, if you left your answer as 4 to 6 in your homework website or on a test, you would be marked wrong. Do you see why? Even though 4 plus 6 is 10, which is a good check that you talked about all the possibilities, notice that 4 and 6 have something in common. They share the factor of 2, don't they? So we can actually divide both of those numbers by the shared factor. 4 divided by 2 is just 2. 6 divided by 2 is just 3. So now we've reduced, which is important to always get your answer right. You want to reduce. We've reduced our odds down, or we've scaled it down to size. So what does that mean? Well, before, if we had a bag of 10 marbles like this, based on the ratio of marbles that we have in the bag, we would have 4 that would be green and 6 which would not. But now if I reduce the bag, instead of 10 marbles and make it half as big, right? Now there's 5 marbles, we would expect the same ratios, the same proportions to apply here. So we'd expect 2 of them to be green and 3 of them not. Okay, so that's what we're talking about there. This would be the correct answer because it's reduced. What about the odds against choosing red? Do you have to do any work there? I hope not. Because if you already have the odds in favor of getting red, what do I need to do to get this answer? That's right, just flip them. So failure to success in this case would be 7 to 3. So the odds against getting red was 7 to 3. Finally, it asked me for the odds against choosing yellow. Okay, odds against choosing yellow. So that would be failure, odds against, right? Failure to success for yellow. How many ways can I fail to get a yellow marble? Well, there's only 1 yellow marble in a bag of 10, so I can fail 9 different ways, right? And I can only succeed the one time I get the yellow marble. So the odds are against me, 9 to 1. If I was a betting person, I would not bet on this one. Okay. All right, so we've given you an example here, a very simple one, when you have just 10 items that you're selecting from, and you're asked to find the odds. The key things to look for, odds in favor versus odds against, stacking them up in the right place, whether you use the shortcut or the formula, and secondly, do you need to reduce? All right, once you have that down, let's head to our next slide. Suppose instead of marbles, we're talking money. So we have a wallet. Hopefully it's your wallet. You're not looking at anyone else's. And in this wallet, there happen to be 6 $1 bills, 2 $5 bills, 3 $10 bills, 1 $20 bill, 2 $50 bills, and 3 $100 bills. Okay. So it doesn't matter the currency. This is just an example of having different items that we're choosing from. Okay. So if I were starting this problem out, whether I'm doing an odds problem or a probability problem, they're technically the same thing, but saying them differently, right? I would want to know how many total bills I have in the wallet, right? So I have 6, which are $1 bills. I have 2, which are $5 bills. So far that's 8 bills. I have 3 $10 bills, so now I'm at 11 bills. I have 1 $20 bill, so now I'm at 12 bills. I have 2 $50 bills, now I'm at 14 bills. And I have 3 $100 bills, so now I'm at 15 bills. So I have 15 bills I'm holding out, and maybe you're blindfolding someone and saying, pick one of these and you get to keep it. Hopefully they pick the $1 bill for your sake, right? Okay, now if someone asked you in a math class like this, find the probability of selecting a $5 bill in this scenario. As soon as you see the P for probability, what kind of notation should you be using? Should I write the colon, dot, dot, the vertical dot, dot, which means something to something? Or should I put a fraction, a line with a numerator and a denominator? That's right, we want a fraction, because probability is simply the number of ways possible to be successful over the total number of possibilities. So how many ways can I successfully choose a $5 bill in this scenario? Well, there's just 2 $5 bills, so I would say 2. Out of how many total bills? How many did we say there were? I believe we said 15, right? 15? Or I think I said 17. Let me add up again. We had 6 plus 2 is 8. 8 plus 3 is 11. 12, 14, and 17. Yes. So if I said anything else but 17, that was a mistake. All right, so 2 out of 17. So at this point, you can't reduce, right? One's even, one's odd. That would be your answer. Usually that's how we like it in a math context as a fraction. But for practical purposes, you could then open up a calculator, type it in, and get an approximation for your decimal. And I got roughly 0.1176 before I rounded, or roughly as a percentage, 11.8%. Okay, so depending on how they would like the answer presented. They'll usually tell you where to round if it's a decimal or a percent. What about the probability of not selecting the $5 bill? Not selecting. Well, we talked about that last time in our previous video. The probability of not picking something or not doing something is 1 minus the probability of doing something. So we could just say this is 1 minus the probability of selecting the $5 bill, or 1 minus 2 out of 17. In other words, since 1 is really 17 over 17, you'd have 17 over 17 minus 2 over 17. I know some basic math that might be a little bit annoying if you haven't done this in a while. 15 over 17 would be our answer. That's supposed to be a 7. Okay. Now you could have just gotten that by directly looking at the problem, right? How many bills are not $5 bills? Adding them up. There's 15. 15 over 17 is the answer. And then let me clean that up because that's a really ugly 7. Okay, there we go. And then if you wanted to make this into a decimal or into a percent again, all you do is type 15 divided by 17 in your calculator. And I believe as a percentage, we get 88.2% roughly, which should make sense because these events, if you remember from our previous video, are complementary, right? Either you do get a $5 bill or you don't get a $5 bill. Together, the complementary events have probabilities which always add up to 100% or 1. Next up, we're asked to find the odds in favor of selecting a $5 bill. Now notice here the wording. It sounds like we've done this problem already, doesn't it? But in reality, the way that they like the answer is different. Before they asked for probability, and now they want odds in favor. So for odds in favor, remember that shortcut? It's going to be something to something, success to failure. So in this case, what would that look like? How many ways could I successfully choose a $5 bill? Just 2. And how many ways could I fail? Now, this is a mistake I see often. A lot of students want to put the total here. They want to put 17, but that's not accurate. How many bills do I have which are not favorable, which are not $5 bills? Wouldn't that be 17 minus the 2 that I've already used? So 15. And in fact, you can add them up, right? Look at all the components in the wallet. 15 of them are not $5 bills. So 2 to 15 would be the odds in my favor of selecting a $5 bill. Okay. Now in this case, I cannot reduce, but if they had been a 3 and a 15, I would have reduced. You see the difference? Okay. Also note that 2 plus 15, because I haven't reduced, does add up to the total of 17. So that's another way to check. Odds, if you have not reduced, should always add up when you add the favorability and the non-favorability, succeeding and the failing. They should always add up to the total. What about the odds against selecting that $5 bill? That should be the easiest problem on the whole slide. What did you say? 15 to 2 is correct. It's simply flipped. So instead of success to failure, you look for failure to success. 15 ways to fail, 2 ways to succeed. All right. Once you think you understand how we've done odds so far, join me on the next slide and let's do some more complicated things. Speaking of complicated, do you remember what happens when we have a deck of cards? We talked about this a little bit last time. So if you have a deck of cards, it might be helpful to get it out and to kind of analyze the situation. I've also provided here a nice picture of a deck of cards, what's in it. So in a standard 52 card deck, there are, again, 4 suits of 13. In each suit, you have the same cards, but they're just a different color and a different style. So for example, you have black clubs at the top here. You have black spades. You have red hearts. And you have red diamonds. Those are your 4 types of suits, and then there are 13 cards in each suit. Now, for our purposes, when we talk about math and probability, we're always considering this ace card to be low. If you ever play cards, they'll talk about a low ace versus a high ace, which means it's the equivalent of the number 1, okay? So we're going to be using it as a low ace. Then you have the numbers 2 through 10 inclusively, and then the jack, the queen, and the king, which typically have a value of 10, but they might have different significances depending on the game of cards you're playing. Okay, and also keep in mind, if they talk about in your homework the words face cards or picture cards, they're synonymous. They mean the same thing. And what they mean is a jack, a queen, or a king, because notice they each have a picture, okay, or a face of a human. Okay, so when we're talking about cards, this is the scenario. Notice that there's 4 suits of 13. How many total cards are there? 4 times 13 is 52. So with this out there, once you have it on display, let's see if we can answer the question. It says, can you find the odds against choosing a king? And I'm going to encourage you to pause the video if you haven't already done so and try this one on your own. You have all the skills you need, I promise. Okay, so the odds against choosing a king. So I have my deck of cards here, and I'm going to pull out one card. What are the odds against it being a king? Let's think about this, and I'll kind of cheat. Is it a king? Nah, it's a jack, so we didn't quite get there. But let's see what the odds against getting a king would be. So heading back to our slide here, what would we write down first? Odds against choosing a king. Well, since it's odds against, we'd say how many ways could I fail, right? How many ways could I fail to how many ways could I succeed? So how many ways could you fail at getting a king? Well, I don't want to add up all the different number of cards here, so what I'm going to do is be a little clever. How many kings are there? 1, 2, 3, 4, right? 4 kings because 1 for each suit of 4 suits. So I simply subtract 4 from 52. That leaves me with 48 non-kings. Okay, so that's a little bit easier that way than simply counting them all, right? So this would be 48 ways against me. And how many ways could I successfully have gotten a king? Just 4. So you can tell already the odds are stacked against me, I hope, right? And notice that 48 plus 4 we have not reduced yet. So when you add them together, you get 52, which is the total, okay? So you know you have accounted for everything. But I can reduce here, and what do I get? If I notice that 48 and 4 are not only both divisible by 2, but they're both divisible by 4. That's right. 4 goes into 48 12 times. 4 goes into 4 1 time, which means for every 13 cards, if I shrink this down to scale, 12 of them are not favorable to me. 12 of them are not kings, and 1 of them is. Okay, just like what happens in a suit. All right, so 12 to 1. On the other hand, if they ask for the odds in favor of choosing a face card, what would this be? Try it on your own. Okay, let's see how you did. In favor of getting a face card, we want success, because it's favorable here. Success to failure. So how many ways could I successfully choose a face card? How many face cards are there? Jack, queen, king. So 3 for every single suit. How many suits are there? 4. 3 times 4 is 12. So there are 12 face cards here. These are the 12 face cards or picture cards. So 12 favorable ways to do this. So how many cards by default then, by subtraction from the total, how many cards are going to be failures for us? In other words, not face cards. Well, subtracting 52 minus 12 gives us just 40. So there are 40 cards which are in this category here, which are not face cards. So you can see that here as well. If you simply notice that there are going to be 10 times 4, because there's 4 suits, you get 40. Again, if you notice here, before reducing 12 to 40, our answer does add up to 52. So you've accounted for all your possibilities. But because they are both divisible by something, do you see what number? By 4, that's right. What does this reduce to? Yeah, 12 divided by 4 is 3, and 40 divided by 4 is 10. So for every 13 cards, 3 of them are favorable to us, 10 of them are not favorable to us. 3 of them are face cards, 10 of them are not expected to be. So again, I probably wouldn't bet on that as well if I was a betting person, but I surely would bet on this first one if I was a betting person. 12 to 1, those are odds in my favor. I like that. Okay, so let's head over to another problem where we go back and forth between odds and probability. Okay, so regardless of what you think about this problem, just look at the math with me. Here we go. On the week of the 2016 US election, the average of all polls, I believe I checked on a Monday that year, the average of all polls showed that Donald J. Trump had a 29% likelihood chance of winning the Electoral College to become president of the United States. What were the odds against him winning the election? Okay, so what you notice here is you are given what? You're given the probability that Trump would win, according to the average of all the polls at that point in time. Every day was a little bit different, but the day I checked, that was what it was that week. Okay, so that was 29%. Now, what are they asking you to do? They're asking you to go from a percent, which was a probability, right? So you're given a probability as a percentage. They could have also given this to you as a fraction or a decimal, so keep that in mind. And they would like you, so what do they want you to do? They would like you to turn this into an odds problem. So they want odds against. Now, the reason this might be helpful is sometimes you go to websites and they'll actually tell you the betting odds against or for something. And so you want to be comfortable going back and forth between probabilities and odds. Okay, so to calculate the odds against, what do you need to do? You need something to something if you're using the shortcut, right? Failure to success. So how many ways, in theory here, according to what we know, could he fail to win the election, the Electoral College, and how many ways could he succeed? Well, you might be thinking, I don't have enough information. They didn't give me marbles, they didn't give me cards, right? But if we understand the concept of percent, we can do this. A percentage literally means out of every 100 items or opportunities or trials, in this case, 29 are in our favor. So we could rewrite this as 29 out of 100. Percent comes from the Latin. So por ciento, that's a Spanish version of it. But it's basic, the idea is for every 100, how many are in your favor? So 29 out of every 100 are in your favor. With that in mind, could you now do this if you know that for every 100, 29 are in your favor? Well, yes. So we could then say, in this case, that the number of possible ways to succeed are 29, and the number of ways to fail would be 100 minus 29, which is 71, right? So for every 100, there would be 71 ways that he could not win, but 29 ways that he could. Okay, that's what this is saying. Now, since there's no way to reduce, we would have that as our final answer. Okay, so again, what did I do here? I recognized that I was given a percentage, a probability. I needed to make it into an odds format. In order to do so, I changed the percentage into something out of 100. Now I know out of this many total, this many are favorable to me. And then from their subtraction, I can get how many are unfavorable. Okay. Now that we've gone in that direction, let's hit our last example, going the other way. That same year, in 2016, the last week of the MLB World Series was occurring, and I went and checked that the betting odds in favor of the Chicago Cubs winning the World Series were 6-1. So we're given that the odds in favor that they win, so of a Cubs win. So we're given that that was 6-1. And what do we want? This time they would like me to make it into a probability. So how likely is this as a percentage, let's say? So what do we need to do to change this to a percentage? Well, we could notice that we need for a percentage the probability that the Cubs win. That's what we're after, right? We need the total number of possibilities on the denominator, and we need the number of ways this could happen in the numerator. So what does this odds in favor tell me? Odds in favor tell me there are 6 ways that you could successfully have the Cubs win for every 1 way that they could fail to win, right? So how many possibilities is that describing? 6 plus 1 is 7. So for every 7 possibilities, 6 of them are in the Cubs' favor, and 1 of them is not, okay? So how would I write that? Out of every 7 possibilities, let me scoot that up so you can see my 7. Out of every 7 possibilities, is that better? A little bit. How many of them were in my favor for the Cubs to win? 6. So you could say the answer is 6/7, but keep in mind, typically you like to see probability in terms of percentages. So let's go to our calculator. I think I can pull one up here. Let's see if I get lucky. Ah, there's one. What do we know? So what I'm going to do here on my graphing calculator is type 6. Let's see, oops, let me switch to the correct tool there for you. All right, so let's pick that tool. 6 divided by 7. Now you can do this in any calculator, but I wanted to show you a cool feature that the graphing calculator has. Notice it gives me an answer right now of 0.85714, et cetera, et cetera, et cetera. So there are many, many decimals there, and typically you would round this to like 85 point, I would say this is roughly, oopsies, let me grab my pen. Let me get that back for you. Okay, so it was 0.857. So now I'm going to round this to roughly 85.7%. So they had a pretty good likelihood of winning the World Series according to this information. But what I like to show you is if you're playing with your calculator, especially these graphing calculators, you can actually take a decimal and you can go back and forth. So you can go from, in this case, the decimal to the fraction itself by hitting the math button here. Let's see if you can see this with me. Okay. There we go. I think you see it now. If you hit the math button, it's a little small, but bear with me. Hit the math button, and then I would like you to hit the very first selection, which is changing to a fraction. It says like an arrow to the right, frac, or number 1 if you hit enter. What that does is it takes your answer and converts it to a fraction if possible. So let's see what happens in this case. Cool, it just became 6/7. So if you're ever doing your homework and you're trying to switch back and forth between decimals and fractions, keep that button in mind if you're using a graphing calculator. Scientific calculators also have skills like that, tools like that. You can always reach out to me about your particular calculator, but just be aware the technology can help you if you're having trouble going back and forth. All right, well, at this point, we've talked a lot about odds and probability. At this point, it's up to you to practice because math is not a spectator sport. I'll see you next time.